Okay, we're doing Coulomb's law, but it's going to be this time arranged as a triangle. Specifically, it's going to be a right angle triangle, which in terms of the ones that we're doing, this is much easier because you've got a 90-degree angle, which means you've got a y and an x predetermined for you. We got determining the net force on charge A, so this is the one here that we're looking for. So this is positive 1.5 microcoulombs, so that means A is positive. B is positive 3.5 microcoulombs, so that's positive. And C is a negative 2 microcoulombs. What I need to do first of all is figure out the direction of my forces. So positive and negative means that this positive is going to be pulled this way. And positive means that this positive is going to be pushed that way. Now the fact is that this thing and this thing are also being forced, but we don't care how they're being forced. We only care about A, because that's what's in question. A, right? Now we want to determine the net force, so we're going to find out some other well, actually, I got a theta value here. This theta value is really not the one I'm interested in. I'm interested in this one here. And since I have opposite and hypotenuse, that's easy enough. Sine of theta is opposite over hypotenuse. So my theta value then ends up working out to 60 degrees. So this is 60 degrees right here. That makes that easy enough because when I draw in my dotted line, that means that's 30 degrees because it's a right triangle. So now I have my angle. I can figure out everything else I need to figure out. So first thing I'm going to do, I'm going to find out my force between charges A, B. So A, B, and C. So that means I'm going to get a repulsive force, and I can just figure out the value of it. 9 times 10 to the 9 of 1.5 times 10 to the minus 6, and 3.5 times 10 to the minus 6 over distance between them, 10 centimeters, 0.1 squared. So my force AB is going to end up being 4.73 newtons up. Okay, because it's pointing upward, so that gives us our direction. I also want to find FAC, and that's going to be the one that's going to give me a little bit more grief in a second. So let's just plug in our values here. And notice again that I didn't bother putting the negative in for that 2 because 0.15 squared. Because the negative doesn't need, you don't need it here because it's going to be a direction anyways, and we don't care about the negative for now. That ends up being 1.2 newtons at 30 degrees, and it's south of east. As soon as you see this, that means you have components, x's and y's. So let's take a different color here. Make my x components of this, that's going to be FACX, and you're also going to get a y component to that right here, which is going to be FACY. And I guess since I've gone in reds here, I should make that thing red, but what are you going to do? All right, let's find our components. FACX is going to end up being 1.2 cosine of 30 degrees, which means that is 1.04 newtons, and look at the direction, it's right. And then my FACY is going to be 1.2 sine of 30 degrees, which will end up being 0.6 newtons, and look at the direction, it's down. So now all we got to do is map out our ups and downs together and our rights and lefts together, and there is no left, so it's going to be right. And now I just got to see about my ups and downs. So if this is an up, that means that this technically is a y. So let's do a sum of my x's, or x total is just 1.04 newtons right. That's all I've got. My yt though is going to be an up and a down, so 4.73. Up is always positive, down is always negative, so I'm just going to subtract that 0.6, and that's going to end up giving me a value of 4.13 newtons up. Okay, so let's just cloud those things up. Quick sketch. will give me a little bit of a hint in my direction here. My x is to the right, my y is up. So there is going to be my F net that I'm looking for, and that's going to be the angle that it's directed at. So my F net I find by going square root of x squared plus y squared. And so my F net value ends up being, let's see here, F net will end up being 4.26 newtons. And then we want to find out my angle. So this is my y is 4.13, my x is 1.04. I'll go tangent, opposite over adjacent, 4.13 over 1.04. And my theta value ends up being 76 degrees. So that's going to be at 76 degrees. And then look at it, it's north of east. There you go. That is right triangles. Coulomb's law with right triangles. Quite a lot of work, but there you go.